In this demo, we're going to be looking at kind of the most basic approach for launching a new steel beam calculation, and that'll be for launching a steel beam that doesn't have any Revit load objects placed on it in the Revit environment. This could be if you simply aren't a fan of Revit load objects and don't want to work with them directly, or if you have a project or a particular element that's simple enough that you don't need to or want to model those in Revit. So I'm going to go to, you'll notice in this view of our demonstration building, I have our I have our analytical elements turned off, and I'm going to toggle over to our other second floor 3D view here. You can see that we have a clear span girder with a series of beams bearing on it for kind of this main entrance element. And some of these beams have Revit load objects on them. We're going to focus on the one beam here that does not, so that we can demonstrate just a basic steel beam launch process. So let's just quickly go to the second floor view, plan view, and take a look at the properties of this beam. You can see from our dimension strings that have been placed on the plan here, we have our beams spaced at 6 feet on center. And we would expect this calculation when it arrives in ENERCALC to show us accurate span geometry. So what we see is that we have a 12'6" back span and then a 9'6" overhang on this cantilever beam. So in order to launch a calculation for this beam, you'll simply navigate to the ENERCALC SEL tab up here, and you can either click Steel Beam and it'll wait for you to pick the element, or conversely, you can grab the element and then navigate to the tab and click Steel Beam to launch the calculation. When the calculation launches, the first step of the process is the program is going to wait for you to confirm the support conditions. So it automatically detects that this beam is spanning from girder to girder, and it shows us those girders for approval. We can freely navigate and interact with the Revit interface while this is happening. We can even toggle to other views and see what's being shown. And if you ever have a complex framing situation where the support conditions are more difficult to predict, you can always intervene manually with this Select Supports Manually control. In this case, I'm going to simply confirm these supports, and I'll also confirm that there are no tributary beams bearing on this beam. Once I finish those approvals, it'll proceed with launching the calculation, and that calculation is going to populate automatically in the ENERCALC interface. And there's two things to note about that, just briefly. If ENERCALC is not open at the time that you launch that calculation, it'll be opened for you. If ENERCALC is open, but a different project is active or no project is active, the appropriate project will be retrieved for you. So we see in our loading diagram here and our span geometry diagram, we have two spans as we expected. We have a cantilever span at 9.5 feet, and we have a back span at 12.5 feet, but we don't have any loads applied to the beam at this time. The reason being that the Revit element didn't have any loads placed on it. So I'm going to simply navigate to the Loads All Spans tab and manually apply some loads. I'm going to use 20 dead and 20 roof live, and then apply a 6-foot tributary width to get those linear loads based on that geometry that we saw in the plan view. Now that we see these loads have been applied here, I'm going to go back to our calculation tab, and I'm going to go ahead and manually change the beam section size to get just a little more efficiency, and we'll be able to see that section size update when we arrive back in the Revit environment. Now I'll simply give it a name. We'll call this Sample Overhang Beam, and we'll save and close. And when we get back in Revit, we see that this beam is now green highlighted. We see that it has a W10x12 section size as we selected in the ENERCALC environment. And we see that the loads that we applied in ENERCALC have been stored here in the Revit model for future use on relaunches of the calculation. And if we want to see calculation details about this beam, we can simply navigate to the element manager, pick this beam, and view the calculation results, including the bending, the shear, and even open a calculation report if desired.